Okay, let's start again. We're doing 5.7. Welcome back. Hope everything is exciting in your life, or are you just staying home and enjoying being at home? You don't have to get up and try to drive and rush and deal with traffic and etc. to get to school. You're able to stay home and do what you have to do, so that's good. Let's go ahead and get started with 5.7. 5.7 is called special products. 5.7 is called special products. So we're still multiplying, but these are some special situations that occur when in algebra when we're multiplying polynomials, and more specifically binomials. So what we have is our first set, and that is in essence a plus b times a plus b. So squaring a binomial. When we move on to chapter 6, we'll know that this is called the perfect square trinomial. So as we move forward, we'll call this the perfect square trinomial. But instead of perfect square, your book calls it the squaring the binomial. But I like perfect square trinomial because that's what we're going to call it down the road anyway. All right, so let's continue. Let's go ahead and talk about it. Let's say I had a plus b squared. Well, what does a plus b squared really mean? It means a plus b times a plus b. Well, let's figure out what this is. Well, we just figured out last time we can FOIL this because it's two binomials in the last section in 5.6. We realized we can FOIL or even distribute, whichever one works for you. We're going to do the a times a is a squared. A times b is ab. B times a is same as ba. Remember that ba is equal to ab. So I'm going to do plus ab and then plus b squared. So remember ba is the same as ab. So I'm going to put ab instead of ba. So this was ba first, and then I changed it to ab. Now I'm going to combine like terms, and I get a squared plus 2ab plus b squared. And this is the formula for a perfect square trinomial. Please remember this for future reference, because I am liable to do a quiz and let you give me exactly what it is without actually being able to multiply it out. It'll be like a 5-minute quiz, and you'll have to. It is what it is. You got to get it. Either you got it or you don't. It's not any time to get that answer. So as we move forward, a plus b squared. Let's look at this idea. Essentially, I want to make a point. A plus b squared, and this is a pet peeve for many mathematicians, and we say that does not equal a squared plus b squared. Again, remember that is voodoo algebra. We literally, you took your wand out and said, boom, this is what I want you to do. Here's your wand, and you said, boom, turn it, do it, and that's it. No, you cannot do that. That is voodoo algebra. This is our formula for the perfect square trinomial. Notice what happened. What did we do? We squared the first. That is our a squared. Then we squared. Sorry, my usual alarms for my classes are going off. Squared the last one. That's your b squared. Yes. Then we multiplied the first time the last. So the first times the last, and then doubled it. So that's what we did. We squared the first, we squared the last, we multiplied the first times the last, and doubled it. Okay, so that's essentially what we're doing. This is our 2ab. Let's put it into action. I'm going to multiply it out once. No, we've done that before. I'm just going to go straight to the answer and talk about what it is. So let's do number 14. Number 14. Number 14. Now, you can multiply this out. It will work. But we should know this formula because we're going to need it, especially in the next subsequent class, but also in the next chapter. So let's take 6y plus 13. This is a y. You could have called it a g. Variable is a variable. So we have 6y plus 3 squared. So it says square the first. So that would be 6y squared. Then we're going to square the last, which is plus 3 squared. Then we're going to work the middle. So this is working the middle. We're going to multiply 6y times 3 and then double it times that by 2. That's essentially what we're doing. We're squaring the first, that's our a squared, squaring the last, that's the b squared, multiply them together, and then double it. Let's put it into action. Let's simplify it. 6y squared is just 36y squared. 6 times 3 is 18 times 2 is 36y plus 9, and that's my answer. And this keeps me from having to necessarily FOIL it out, combine like terms. I mean, you can. It will still work. Case in point, this really is 6y plus 3 times 6y plus 3. And if we FOIL it out, we get 36y squared plus 18y plus 18y plus 9. And we can see from combining like terms that that's the exact same thing. Those are equal. So that is good. All right. Let's do another one. Let's do number 16 this time. So let's look at number 16. What does 16 say? Well, what does 16 say? Let's see. 16 says 9b minus 2 squared. Now, at this time, you should pause it and try it out on your own. But for recording's sake, I can't pause it and try it out on my own, so we have to go ahead and go through. But you should pause it and try it. So let's go to work. I'm going to square the first one. If I square the first one, I get 81b squared. If I square the last one, don't I get a negative 2 times a negative 2, which is a positive 4? And then we're going to multiply them. So if I multiply them, I get negative 18b, and I double it, I get negative 36b. And guess what? That's my answer. 81b squared minus 36b plus 4. And that's my answer. Okie dokie. Let's move on then to a different kind. And we call this the difference of two squares. The difference of two squares. Now, this is one that I'm not going to have patience if you don't know this one. This is like my ace all end of be all. This is the one I really won't have too much patience if people don't know this. I think we should know this, no problem. They call this the product of a sum and difference. This is what your book calls it. The product of a sum and difference. Essentially, it's a plus b times a minus b. Let's multiply that out and see what we get when we do this. Let's multiply it out. We get a squared minus ab plus ba minus b squared. But we know that ab is the same as ba. So what happens to the two in the middle? Don't they just cancel out? Because a negative ab plus a positive ab is just no ab's. So we're left with a squared minus b squared. So essentially our formula for the difference of two squares is a plus b times a minus b is equal to a squared minus b squared. This is the second formula you should know by heart. I gave you the first formula, the perfect square trinomial, or the square of a binomial. And then this is the difference of two squares. All right, so let's put it into action. And it works just like that. I don't need to multiply it out. I can go straight to it for what it is. You can multiply it out to check yourself, but essentially we can go straight to it. Excuse me. I have never told you what page we're on. Excuse me. We're on page 409. Again, we're on page 409. So let's look at number 26. And I do apologize for not telling you what page we are on. We have y plus 6 times y minus 6. Well, it's the first one squared minus the second one squared. So the first one squared is y squared. Second one squared is 36. So it's just y squared minus 36. Let's try another one. Let's do number 28. 28. It is 5t plus 4 times 5t minus 4. 5t plus 4 times 5t minus 4. Well, it's the first one squared, which is 25t squared, minus the second one squared, which is minus 16. And guess what? That's it. Let's try 32. And why don't you pause it and try it yourself? You try. But I'm going to keep going. But I think you should try. You would benefit from it. Let's take m plus 4/5 times m minus 4/5. If you take m plus 4/5 times m minus 4/5, we end up with m squared minus 16 over 25. And that's it. That is it. All right. So what if we have a plus b raised to higher powers of a polynomial? What if we have higher and higher powers of a binomial? So if we have higher powers of a binomial. For example, if I had a plus b cubed, what you want to do is you want to do a plus b times a plus b times a plus b, and just break it down. That's exactly how you want to format it. And then once you do two of them, once you multiply two of them, then you can multiply the third one using distribution. And when you do that, you'll end up with a cubed plus 3a squared b plus 3ab squared plus b cubed. Say okay. What I would like you to do is try it yourself. Multiply and distribute that out and make sure you get that answer. Maybe you want to push pause now and make sure you get that answer. Make sure I'm telling the truth. Because can you trust me? I hope you can. But try it out and see. And make sure that that is what you get. Let's put a couple problems in action. Let's do number 40. 40. Let's take m minus 5 cubed. This is number 40, by the way. So essentially this is m minus 5 times m minus 5 times m minus 5. When I do that, I'm going to multiply these two right here. Now remember, that's the same as the first formula that we learned. Take the first squared, take the second one squared, multiply them, get negative 5m, and double it, I get minus 10m. So we have that. Then you've got this m minus 5 in front, and that's what we have. Okay? Then, after we do that, now we're going to distribute. Just straight through, we're going to distribute. Once we do that, we end up with, well, what do we end up with? We end up with m times m squared. That's m cubed. Then we end up with m times 10 to the m. Minus 10m, excuse me. Incorrect saying it. Apologize. Minus 10m squared. Then we have, oops, forgot about that one. Then we have, let's go to the third one, and then we have m times 25, which is plus 25m. Come on, mind, chill out. Okay. I think I'm running out of room. I think I didn't leave myself enough room. Ooh, that was real smart. Okay, so now let's do the second one. Let's do a different color. What color we're going to do? Let's pick green. Where's my green marker? There's green. There we go. So now we're going to do negative 5 times m squared. So I get a negative 5m squared. Negative 5 times 10m. So I get a plus 50m. And negative 5 times 25, which is a negative 125. Okay? Once we do that, let's add it. We end up with m cubed minus 15m squared plus 75m minus 125. And guess what? That is our answer. All right, so let's summarize everything that we've done and put them all in pretty much the same problem. And so we're going to approach it the same way as we normally approach things. We multiply first, and then we add. We get rid of our parentheses, and then we add. We know our order of operations. We can handle it. Let's make it a little harder math problems. Let's try number 46. I'm going to do number 46. Number 46. Number 46 says, what does 46 say? Let's see, 2t times t plus 2. Oh, I miss y'all so much. I want you to know, I really do. I'm like going crazy up here. I'm by myself. I don't have nobody to talk to, nobody to laugh, nobody to, bounce ideas off of. Maybe somebody can explain it a better way than I can. But use your discussion board. The discussion board is there. Feel free to make comments and explain it a different way. That might be a little bit better for your classmates. Your classmates might benefit from it. They might appreciate you for doing that. And go ahead and feel free to do that as you go forward. Okay, so let's go to work. So we've got this. First step of any math problem, write it down. That's the first step. Did you write it down? Or are you just watching me? Oh dear, I hope you wrote it down. I wish you could see me right now. Maybe if I put my face, maybe if I arrow it. Nope, that's my shirt. Nope, I'm upside down. Please write it down. Okay. All right, gotta have some fun in our video. Okay, all right, let's go to work. So we're talking about this problem here. What do you think we're going to do first? We're going to distribute. Get rid of our parentheses first. So if I distribute, I end up with 2t squared. Yes? And then draw the second arrow, and I end up with 4t. That's the first half. Then you got this big plus sign in the middle. And then we got to do the second half. The second half is, well, let's FOIL it. Isn't that a FOIL problem? And I get t squared, or distribute, whichever one, plus 9t minus t minus 9. And of course, you've done a lot of the homework already, so you are already familiar. If we went to look at WebAssign, and we went and found WebAssign online to see exactly what is due, when is due, etc., I mean, what section is what, we could go find out. We can go find. Now let's see if we remember our username. Can't remember, is it with Oakland CC or is it just straight? I think it's straight. Nope. Where's my email? Yep. Maybe not gonna remember that. So let's go down here. So notice that you should have already done 5.1 to 5.3. Now we're working on 5.4 to 5.8. And so we're on 5.7. So if we preview this assignment, you should be able to do, right after we finish this section, you should be able to do, let's go all the way down here to the bottom, because I know I'm all the way at the bottom. You should be able to do 23, 22 and 23, 21. So starting at about, I would say 20. Nope, going back up, back up, back up, up. So about 16. 16 going forward, you should be able to do these problems that we're doing now. So 16 through 24 you should be able to do after we finish this section. So hopefully you're working on your homework and doing that and going forward. Okay. So let's go ahead, because it is still part of your grade. Even though we're on these videos, they're still part of your grade. So I don't want you to think that your homework's free now. Still have to do your homework. So let's go back to work. So we're on this problem. And so we want to combine like terms. So let's combine. Let's see. Let's have some fun. Well, I've got 2t squared and a t squared. So how many t squareds I got? Exactly, 3t squared. Cross that out. So here we go. 4t plus 9t is 13t. Minus t is how many? Exactly, 12t. Very good. And then I've got the minus 9. And guess what? Exactly, we're done. Hey, work it. Oh, let's do number 52. All right, let's do 52. You try 52. You should try 52. Again, what should you do? You should try 52. Pause. You should be trying 52 right now. I'm hoping that you're trying 52 right now. So I'm going to just, and so here at me, I'm coming with the answer to 52. Hopefully you push pause, and now we're pushing play to make sure we get the same answer. We're going to multiply these two first, and so we're going to just go straight through. We get x squared. This is the difference of two squares, so I get 8y times x squared is x to the fourth, minus y squared times y squared is minus y to the fourth, and then times it by 8y, so I get 8x to the fourth y. Notice I didn't change the power because this doesn't have a y in it, but this does, so that becomes S8y to the 5th. They have to have the same basis to be playing with their exponents. Are y'all with me? You have to have the same base to be able to change the exponents when we're multiplying. Okay, let's do one more problem, and that is a geometric problem. It says to find the area of the figure and leave pi in your answer. So here's a circle. You know I can't draw, so just deal with it. And then they gave us a radius of x minus 3 inches. So our radius is x minus 3 inches, just in case you can't see that inch. All right, let's see. What are we going to do with this? Well, I know the formula for the area of a circle is pi r squared. And they want me to leave the pi in the thing. So do not get busy and start typing 3.14. We are past that stage. You have a pi button on your calculator. Hello. So do not put the pi in. We're going to leave it. What we want to focus on is the r squared. Well, what is our r? Our r is x minus 3. So essentially this becomes pi times x minus 3 squared. So let's do it. Well, we know this is the perfect square trinomial, or the product of the square of a binomial. What is our step to do that? Let's see if we remember. Square the first one. Square the second one. Multiply them. If I multiply, I get negative 3x. Double it, I get negative 6x. Let's review that. Square the first one. Square the second one. Multiply them. And double it. And there we have it. Times pi inches squared. And that is my answer for my area. Okie dokie. Very good, everyone. Let's move on then to 5.8. Let's see how you do with 5.8. Some people don't really like this section. You find out. But again, you do stuff the way that works for you. But even if we don't like it, we just can't be afraid of it. I don't care if you don't like the math. You just can't be afraid of it. You can throw it. You can have a temper tantrum. I don't care. Just don't be afraid of it. For we don't fear it, we conquer it. So dividing polynomials. Dividing polynomials. I'm going to start off with monomial divided by monomial. When you do monomial divided by monomial, it's essentially just using your exponent rules. So when you do monomial divided by monomial, you're going to be essentially using your exponent rules. Let's get to that page so I can tell you what page we'll be looking at. We'll be looking at page 418. We'll be looking at page 418. So we'll be looking at page 418 for those of you who have the written text or the online text. Scroll down until you get to the answer set. If you get to the review section, that means you went a little too far. If you get to the summary and review, you went a little too far, come back a little up, that's okay. Life happens, don't worry about it. Just get to the part that you need. Alright, so let's go to it. Let's look at let's do number 14. Number 14 says 8 to the 12 divided by 8 to the 8th. 8 to the 12 divided by 8 to the 8th. Well, don't we know exponent rules? What can we do when we see the quotient rule? Quotient rule tells me what can I do with the exponents. I can subtract them, exactly. So I got 12 on top, 8 on the bottom, so that just leaves me with 4. 8 to the 4th, exactly, very good. Let's do another one. Let's do number 24. And I hope you're pausing it and you're trying it first. Negative 35, x z to the 6 over negative 7, x to the 8th, z squared. And don't forget, there's nothing wrong with doing your fingers. Keeping track of it using our fingers. Remember we talked about this many on top, this many on bottom, and what do? They cancel out, and how many do we have left? So don't forget that you can use your fingers. That'll help you keep in mind of what you have going on. So let's do it. First of all, we start off with negative 35 divided by a negative 7. Well, a negative divided by a negative is a positive 5. X over x to the 8th. Well, 1x up here, 8 down here. Doesn't that leave me with 7 on the bottom? And I got z to the 6, z squared. Doesn't that leave me with z to the 4th on top? Guess what? I'm done. Isn't that nice? I had 6 of them. Get your fingers. I'm taking 2 off them. And the quotient rule tells me I can subtract. All right. Great, great, great. Let's move on then to poly divided by a monomial. The key thing for a polynomial divided by a monomial, you have to remember to break it up. Breaking it up is essentially just distributing. That's all you're doing. So when you break it up, you're just essentially just distributing. That's all you're doing. So a polynomial divided by a monomial, you're just breaking it up or distributing. All right. With that being said, let's keep going. So polynomial divided by monomial. You're going to break it up and distribute. So what are we doing? What are we doing? Where am I having a blank? A plus B divided by C is going to be the same as A over C plus B over C. Notice that each term in the numerator is divided by that divisor. So each term in the numerator is divided by the denominator. So we have to break that up. Let's do number 30. Let's do number 30. Let's look at number 30. What number are we looking at? Number 30. We're doing quite a bit today. I got quite a bit of notes here. Pages I've gone through, but we're doing good. Number 30. I want to get through chapter 6 before I leave today. So hopefully we'll be able to do that before tonight is over with. And then I'll have to work on another class. All right, 30. I don't think you really wanted to know all that, did you? Sorry. 4x to the 14th minus 36x to the 8th over 36x to the 12th. You know Miss B is random. She can be random. And I put myself on YouTube being random. Oh! Okay. Here we go. What are we going to do first? First step is to do what? Exactly. Write it down. Did you write it down? Great, great, great. So what are we going to do now? Break it up. So here we go. And I'm going to go this way. And I get 4x to the 14th over 36x to the 12th minus 36x to the 8th over 36x to the 12th. Is everybody with us? We're just breaking it up. This technically is distribution. We're dividing both terms by that same divisor. Okay, so now let's simplify. What happens with the 4? Well, the 4 becomes a 1, 36 becomes a 9. Do we agree? We divide top and bottom by 4. And then we end up with, I got x12 and x14. Well, 12 of them go away, so I'm left with 2. So I'm left with x squared over 9 for the first term. Second term, minus the 36's cancel. I've got, so that leaves me with 1 on top. And then I have 8, I'm taking away, I've got 4 left on the bottom. And this is my expression that's left over. This is not a polynomial. Does anybody know why this is not a polynomial? This expression here is not a polynomial because we have a variable in the denominator. So it's not a polynomial. Just reviewing what we did in 5.2, I think it was, 5.2. We were talking about, no, 5.4, excuse me. When we did in 5.4, talking about what it means to be a polynomial. As soon as you put this here, it became what we call a rational expression, and we'll deal with that in subsequent chapter. Okay, so let's do number 34. 34, let's try 34 this time. And I hope that you are trying, again, reminding you to push pause so you can try and figure it out on your own. So we're doing 12r to the 15th minus 48r to the 12th plus r to the 10th minus 18r to the 8th over 6r to the 10th. So that's what we're doing. We're doing this. All right. What are we going to do first? Yep, break it up. So we're going to break it up. Let's do it. We're going to have 12r to the 15th over 6r to the 10th minus 48r to the 12th over 6r to the 10th plus r to the 10th over 6r to the 10th minus 18r to the 8th over 6r to the 10th. Maybe I shouldn't tell you what numbers we're doing. I don't want to cause that. I hope so. Okay, we'll find out. All right, so here we go. Let's go to work with it. So, as we do these problems, let's go. 6 goes into 12 2 times. So 6 becomes a 2. Do we agree? 15 on top, 10 on bottom, that becomes 2r to the 5th. Minus 8r squared, 12 and 10. Plus, the 6 stays on the bottom. The r10s cancel, so I'm left with 1 6. Minus 3, but then we end up with 2 on the bottom left, so I get r squared. And that is my answer. I hope that you got the same answer as I did. Okie doke. Let's talk about long division. Long division. Long division. Long division. So when we do long division, a lot of times this can be intimidating, and there's some steps that I would like us to utilize, and I'm really curious to find out if I've already have typed these steps, and I hate to do this on my video, but I'm going to do it nonetheless to make sure that I'm curious to find out if I've already typed these steps in here. I'm really curious to find out. 5-point long division. Yes, I have. And so I will make this available to you online. I will make this available to you online. This is our long division. Steps to long division. We're going to write the problem old school. Make sure the dividend is in descending order and every place value is represented. Divide each using first term of the divisor and first term of the dividend. Multiply all terms of the divisor. Subtract by changing the sign of the bottom row. Repeat steps 3 through 5 until finished. And if you have a remainder, write the polynomial as a rational expression. We're going to read that again. Write the problem old school, long division. Make sure your dividend is in descending order with every place value represented, which means every power has to be represented. If the highest one is to the third power, you need squared, you need regular, and you need none. So you need every power represented. Divide using first term of the divisor and first term of the dividend. Multiply all the terms of the divisor. Subtract by changing sign of bottom row. Repeat steps 3 through 5 until finished. And if you have a remainder, write polynomial as a rational expression. So let's get to it. And hopefully maybe you've pushed pause. Maybe you've took a picture of it and you have it next to you. If you want to do that real quick, take a picture of it real quick. So that way you have all those steps, because I'm going to be honest with you, I'm not writing all that. So please feel free to type that, to write that, to take a picture of that, and make sure you have all those steps for long division. Of course, you know I put stuff in my own words, so that's not the exact same thing that you'll find in your book. If you want to find it in your book for long division, you can look at page 415. Will help you with long division. Okay, all right, so let's go to work. So long division, here we go. When we do long division, essentially it's what we know how to do, we just don't like doing it. Let's look at number 42. 42 says 3x squared minus 8x plus 3 over 3x minus 2. Okay, so essentially this is just like the problem. So the first thing, before I get into that, we're going to set it up long division style. And that is putting the 3x minus 2 on the outside, because it's my divisor, going into my dividend, which is 3x squared minus 8x plus 3. So it's my divisor on the outside, going into my dividend of 3x squared minus 8x plus 3. It's just like, and I'm going to do another problem on the side so we can compare notes as to what our next step should be. It's just like 12 going into 132. Essentially, that's what it is. When we did old school division, we would say, how many times does 12 go into 1? It doesn't. So we went 13. Is that right? And we said 12 go into 13 once, and we put the 1 right above the 3 because that's what we were looking at. And so we were looking at both terms. Same idea here. We're going to do 3x goes into 3x squared how many times? And when we do this, and I'm going to change the color so we can keep track of this color scheme. Here, when we divide here, we're going to go on the side and say, what is 3x squared divided by 3x? That's essentially what we're going to say on the side. So when we do that, 3x squared divided by 3x gives us x. And so I'm going to line up my x just like we lined up our 1. Okay, so we got that far. We've got that far. Now, we have to say to ourselves, now what's our next step to do? Well, what don't we do 1 times 12, which gives us 12? Same thing over here. We're going to do x times 3x minus 2. So x times 3x is 3x squared. X times a negative 2x is a minus 2x. Okay? Got that far. Whew, safe. Okay. So let's try it. Let's try some more. And I'm trying to get this brighter. Work with me here. I'm trying to get it brighter. We're having a little trouble. We say technical difficulties. It looks kind of yellowish to me, but we can make deal with it, and we deal with it. Okay. So now, what would we normally do next? Wouldn't we normally subtract? And we subtract, and it becomes 1. Well, remember when we did subtraction in the previous sections? I think it was in section 5.5. We talked about subtracting vertically. When we subtract vertically, all we do is change the sign. So I'm going to start off by changing this to a plus, this to a minus, this to a minus. Did y'all see what I did? I had subtraction there first. So rewind it if you need to. Subtraction, and then we remember every negative, we're going to distribute it, so this becomes a plus, and then we just change the sign. So that negative technically should have been a positive there. That's what we should have changed it to, which is a plus. So now we do it. 3x squared minus 3x squared, that just cancels. Negative x plus 2x is a plus 6x. No, it's not. That's a negative 6x. And we're going to bring down our plus 3. Okay. Just like we would over here, bring down that 2. Same idea. So then we would say to ourselves, what did we say? Ourselves said 12 goes into 12. 12 goes into 12 how many times? Once. Yes? And 1 times 12 is 12, and we get 0. Same idea. Now we're going to go this way. 3x and 6x. So now we're doing the 3x this time and the minus 6x. The 3x minus 6x, well, let's figure it out. Negative 6x divided by 3x. Isn't that just a negative 2? And then we multiply. So now when we multiply, negative 2 times 3x is a negative 6x. Negative 2 times negative 2 is a positive 4. And then we pull it. Is everybody with me so far? I hope you're with me. I hope you're with me. Okay. So then after we do that, we're going to subtract. So remember, whenever we subtract, have this subtraction out inside in the front. We're going to change it, change the sign of the bottom row by changing the signs. We're multiplying, distributing that negative. When we do that, and now we're adding down, remember every subtraction sign can be written as a plus negative. And we get negative 1. Well, Miss B, I have nothing else to pull down. I know. What do we normally call this? We call this the remainder. If we were dividing, for example, if I did 7 divided by 2, and I did 2 goes into 7, goes into 3 minus 6, and I get 1. What would we say our answer was? We would say 3. This becomes my numerator, and this is my denominator. So this becomes 3, 1 over 2. The denominator stays the same. Same idea here. We're going to have x minus 2, and then our remainder of plus a negative 1 divided by 3x minus 2. And there we have that. All right, let's try another problem. Let's try another problem. Ooh, that looks really weird, doesn't it? But we can handle it. Let's do it again. Let's try another one. And I hope you're looking at your steps as we're doing it. So hopefully you took a picture of it with your phone or whatever you did to make sure you have those steps right next door to you as we're moving forward. Let's look at number 48. Number 48. We have 6x plus 1 plus 9x squared divided by 3x plus 1. Oh, I need to put that in parentheses, excuse me. What's the first thing that I noticed? I noticed that this is out of order. It's out of order. It's not in the right order. It has to be in descending order. So if I put it in descending order, I get 9x squared plus 6x plus 1 divided by 3x plus 1. I'm positive. Okay. Yes, ma'am. See you tomorrow. All right, so we did 9x squared plus 6x plus 1. We put it back in descending order. We want it in descending order. What do I mean? The power went 2, then 1, then none. So it needs to be in descending order. Have a good night. All right. I'm not completely alone. I'm giving air hugs and saying goodbye to our colleague. I'm not completely alone, but I tell you, I miss my students. Okay, so let's go to work. Oh, my goodness. I think I'm really about to cry because I really miss my students. I enjoy teaching. I love what I do. Okay, here we go. Let's go to work. So, what are we talking about? I just lost my thought. What number goes on the outside? 3x plus 1. Also notice that every power is represented. We went from 2, then we went to none, then 1, and then we went to none. So every place value is represented. So I can put my dividend in here just like so. Remember, we had to put it in order first. It was not in order, so we had to put it in order and then go straight to it. Okay, so let's do this. What are we going to do? What are we going to do? So let's do divide. So if we divide, we're going to divide 3x into 9x squared. And if you need to, go on the side and see what is 9x squared divided by 3x. Well, I know that 3 goes into 9 3 times, and x goes into x squared, x. All right. Now what do we normally do? We multiply, exactly. So let's multiply. So when we multiply, I end up with 9x squared. And remember, we got to distribute to both of them. You got to do both of them. Can't just do the first one. You got to do both. Plus 3x. Now we subtract. And when we subtract, we need to change the sign. So we're going to change our signs of that bottom row. So the minus becomes a plus, this becomes a minus, this becomes a minus. Notice I changed the sign on everything. I didn't change the sign on one thing. I changed the sign on everything. The 9x squareds cancel. I'm left with 3x plus 1. Okie doke. Now we divide again. So let's do our divisors. Remember, we're only using the first terms, the leading terms of each one. So we're looking at 3x now divided by 3x now. Well, we know that's just 1. And I put a plus 1 to let me know it's going to be a positive 1. And just like we did it before, we have to distribute. So now we're distributing that 1 this time. And remember the both of them. So that gives me 3x. And then 1 times 1 is 1. Now we subtract. Again, remembering to change the sign of that bottom row. So this becomes a plus, this becomes a negative, and now they can cancel. So my 3x cancels, my 1 cancels, I'm left with 0. So my answer is just 3x plus 1 with no remainder. Oh, that was pretty cool. Okay, let's try another one. How do you feel now? Are you feeling a little better, or are you still kind of traumatized? Let's see how we go. Let's try number 50, and hopefully you will try number 50 as soon as we get it set up before I try it. Let's take b squared minus 36 divided by b plus 6. If you notice your dividend here, it's in order, but every place value is not represented. So we can rewrite b squared minus 36 as b squared plus 0b, which is what we call a placeholder, minus 36. So we can rewrite that as b squared plus 0b minus 36, having to put that placeholder in there. And when we do that, we end up with b plus 6 on the outside. And on the inside, we end up with b squared plus 0b minus 36. So let's go to work. Let's have some fun with it. Let's speed it up a little bit. You think we can handle it? Of course, you can always pause and rewind. So even if I'm speeding up a little bit, you can pause and rewind to make sure you have it. At this point, you should be trying it by yourself. So you should have this on pause, trying it to see how you come out, and go from there. B goes into B squared. B goes into B squared, a B. Now we're going to distribute. Same colors we did before. Distribute. Remember both of them. So that gives me B squared plus 6B. Then we're going to subtract. So this becomes a plus. Changing the sign of the second row. And so now I can cancel my B squareds. And end up with negative 6B minus 36. After I do that, I'm going to divide again. Let's divide. And so B goes into negative 6B, negative 6 times. And then negative 6 when we multiply and distribute, just like we did before. Then we end up with a negative 6B minus 36. Again, subtracting on the outside. Now watch this. Watch the signs change. This becomes a plus. This becomes a plus. This becomes a plus. Be careful when you're changing your signs. You've got to be careful of that. Okay. This cancels, and I'm left with what? 0. So my answer is I'm videotaping. Yes, ma'am. How are you? B minus 6. Sorry, I saw another colleague, and I can't be rude and not speak, so I've got to speak to my colleague. So I was letting her know that I was videotaping. So we go from there. All right. With that being said, let's continue. We have finished Chapter 5. Yay! Chapter 5 is now complete. We are done with it. Thank you so much. Again, come online to our virtual office hours so that way we can understand what's going on. That way you can understand what's going on and make sure that we're on the same page. All right. Look forward to seeing you in our virtual online office hours. Thank you.